So I'm a bit excited today. I've just had this package arrived. I must admit I got the idea off Julian Eilert, who's one of my favourite YouTubers for electronic stuff, and he was sponsored by JLC PCB, and I couldn't resist buying something. Now what I've been doing, I've been trying to play with decade counters and 555 timers, very much like he's been doing, and I've been doing it on breadboards. And when I discovered that you could get some prototype PCBs made for so cheaply, I thought that I'd get some done and designed some myself. Now this website, you get a login to this website, but also you get a login to a PC designer as well, and also like a marketplace, community marketplace of people who've already designed and uploaded their projects for free. And when I thought about it, the idea, what I'm trying to do is I'm trying to string a series of these 4017, these decade counters, string them as a series and get a very, very long line of LEDs. That's what I want to do. But then actually having a 555 timer driving into a decade counter isn't rocket science, and it's something I thought someone must have done this. So I found this board already uploaded, and I decided that I'd use that as they knew what they were doing, and get some of those boards printing. Now it cost $2 plus $8 shipping, so about $10, and this arrived today. So there's the pen, very weird pen, but anyway, there's the pen. And I've not opened these yet, so I'm hoping that, oh, there you go, I'm hoping that these will work well. Right, let's try and open these. Alright, they did take a while to come, maybe 2 or 3 weeks. I was just beginning to panic. Then I had to sign for them, and I wasn't in, of course, so then they went back to the post office. And anyway, today they've actually turned up. So they're double-sided, as you can see. It's the reverse side, and there's the side with the decade counter on. Space for a capacitor, space for a variable resistor, and the LEDs. And it looks like there's only one resistor to limit the current to the LEDs. Must be on the journey to ground for them, I think. So there's the 555 that will send the signal in, and there's the counter, and then most of the signals coming out to the counter are going to the LEDs. So I've got lots of these, so I could make them all as standalone units, but what I thought I'd do is make a couple and then try and chop some of the lines on some of them and see if I can get one to feed into the other in the place of the 555 timer. So that's my idea anyway, and I've got 10 to play with. In the meantime, I've been ordering some other bits and bobs for it. There's a 555, so that can go in there as so. I won't do that now. And the only thing I was slightly concerned about was whether these resistors I ordered would fit. So I hope they will. I ordered 2 types, the open cage design, which is what I'm much more familiar with from making kits many years ago, and then the new plasticky design. So I'm thinking that the plasticky design is going to fit in there, and it looks like it. There you go. So that will send the speed of the pulses in. So I'm quite happy with those. I'll stop this video now. When I get all the other bits in, I'll do a build video of it to continue on with this, so you can see one of them working. That's if the guy who designed this board designed it properly, that is. Alright, so there I am then. That's the board populated. I've not put that resistor in, I've put a link. Now that resistor was going from the output of the 555 into the decade counter, and in all the other circuits I've seen there's not been a resistor there. So for this one I've just put a link in instead. So if I get a 5-volt supply, which I've got coming out of this this breadboard, all I should be able to do now is, if I add positive and negative to that, I should start to see the board counting. Now as you see, I can't. So I've spent quite a while trying to diagnose what's wrong with these boards. That resistor being there was the first problem. But in the end, I have established that it's because on this board design, you're supposed to connect pins 2 and 6 of the 555. And for some reason, this board design didn't have those connected. So to establish what was going wrong to begin with, let's show you what I did. I've got a different board here, and you'll note I've actually put a little red LED in it. And if you look at that red LED on this board, it's flashing, but the blue one isn't. So that LED is just going from the output of the 555 to ground. So you should see that it was flashing. So I realised that when I first put that on, it wasn't flashing on just a bare board. So what I've had to do is, behind the scenes, I've had to link those pins 2 and 6 together. And that, I think that is the chip enable. So for some reason this wasn't enabled, and it might be that the guy who designed this board to start with had decided that he didn't want to enable the chip on all of these boards. I don't know if he was doing multiple of them. So what I'll do, I'll get my board that I've just made, and I'm going to link those two together just using an offcut from the LEDs. So bear with while I do that. So it's just a case of getting this pin, this is the second pin down on the side there, on the side nearest the capacitor. So put a blob of solder on there, and then linking that across being careful not to short any of the others out. So I'll just bend that up a little bit, linking that across to the first pin up on the other side. So let me just put this down in a don't burn myself sort of way. So let's just put a blob of solder on that. And hopefully, if I've not shorted anything else out, hopefully now that has linked those two together. I'm going to leave this little bit on at the moment because it's easier if I've left a bit on, if I've done it wrong, to be able to get it off again. And then once I've established that this makes it work, I'm going to remove that other bit. So the moment of truth then. So positive, negative. And there you are. Well, it's counting up a little bit. I may need to adjust the timing of that. Let's just have a go. Okay, there you go then. So I've just plugged this into the 5-volt rail of motherboard, and after a while, there you go, it will start counting up. So this was quite a fun little project. It's nothing I've done before, getting my own PCB created. As I said at the start of this video, I wanted to do this, but then I decided that I may as well get something that somebody else had already designed and just get those printed. So that's what I did. The upshot of that was that I had to diagnose this problem with the board, that that 555 enable pin wasn't grounded. So I had to do that, but that was fine. That was fun because I now understand how the circuit works a little bit more. Also, this resistor that went across there wasn't really needed. It just could be a link instead. The point of these boards is that you create prototypes and then get them made now for pennies, really, for whatever you are designing. I mean, this has been designed purely to get a board printed and to play with it. But I don't think I'm going to be able to, these aren't reliable enough for me to be able to put a string of these together, and you actually need more circuitry, I've found, in the meantime. So I might have to investigate that. But again, nevertheless, a great project and quite an eye-opener that you can get printed circuit boards produced way cheaper than you could probably produce them yourself at home with acid baths and things like that.